Hello, online ag economics students. This week we are looking at chapter 3, which talks about the theory of consumer behavior. A few concepts that we will be learning are, in terms that you'll hear over and over again throughout this lecture, are marginal utility, indifference curves, and the budget constraint. Those are the three major concepts that we are going to be looking at. So in sum, if we're going to summarize the theory of consumer behavior, basically economists are trying to figure out why people choose to buy what they buy and why they choose to buy how much of what they buy. What we know is that two major things play into determining why consumers buy what they buy and why they buy how much they buy. These two things are satisfaction, which means how much satisfaction might a particular good provide for a person. So they are going to purchase something if it brings satisfaction to them. In the economic world, we label that satisfaction term as utility. And then also, can they afford the item? So does the item that they want to purchase fall within their budget? So satisfaction, the item brings them desire, utility, or satisfaction, and they can afford it. Consumers seek to maximize their satisfaction while staying within their budget. So we're going to look at multiple graphs that help show us this. And then why do economists study consumer behavior? Well, from a business standpoint, it's really important to understand why people buy what they buy, why they buy how much of what they buy, when they're going to buy more of what they buy, when they are maybe able or willing to spend more money on a particular item, because ultimately all of this data and all of this information is going to allow businesses to optimize their pricing and increase their profits. So the first thing that we are going to look at is the first aspect of why people buy what they buy, which is people purchase goods because they get some sort of use or satisfaction out of the good that they are purchasing. Now, historically, satisfaction was measured by a nominal numerical value. So we assigned a number to the amount of satisfaction that a person received by obtaining or purchasing a good. This numerical value was given the units of utils, stemming out of the word utility. Okay, so we can sort of think about this a little bit. If I asked you on a scale of 1 to 10, how much satisfaction would you receive out of eating a Reese's peanut butter cup right now? Okay, let's say you haven't had lunch yet. It's been several hours since you ate. Maybe you have a sugar craving. Maybe Reese's peanut butter cups are your favorite candy. So on a scale of 1 out of 10, right now maybe a Reese's peanut butter cup sounds pretty good. So maybe a Reese's peanut butter cup would bring you a satisfaction at about the level of a 9. Okay? So that is the numerical value that they're assigning to the satisfaction that influences people's purchasing decisions. Now let's say you ate that peanut butter cup candy bar, and I might ask you how much a second peanut butter cup would be of value to you. And this may decrease from your first one. Okay, so maybe the first Reese's peanut butter cup you really, really wanted that, so that was a 9 or a 10. The second one, you're feeling pretty full, so a second one isn't really going to bring you that much more satisfaction, maybe a 5. A third one may bring you 0 satisfaction, or it may even dissatisfy you because you are so full it might make you sick. So the idea here is that we measure satisfaction. We used to measure satisfaction in numbers, but increasing the number of an individual good will not always continue to increase at the same rate that the first item satisfied you with. This can apply to anything. So I'm applying this to candy bars, saying more and more candy bars are going to provide you less and less satisfaction till eventually you're going to have a negative satisfaction from them. This could be any good. So if you have, if you have no shoes for whatever reason, you have 0 shoes, one new pair of shoes is probably going to bring you a lot of satisfaction. However, if you already have 5 or 10 or 20 pairs of shoes, that next pair of shoe is not going to bring you very much satisfaction. So we call, when we can plot the various levels of utilities, and we can plot them as a total utility curve. So this graph uses the examples of hamburgers. So for this particular person, one hamburger brings them 20 utils. Remember, we're measuring the utility here in utils. So let's say one hamburger brings them 20 utils of satisfaction. A second hamburger, so the first one brought them 20. The second hamburger brings them to 30. So it brought them basically 10 more. But 10 plus 20 is 30. That's why we plot it here at 30. The third one brought them satisfaction of up to 40, which is another 10. Okay, so that was a total of 40 here. And we can see the next one is not a full 10. It's maybe at a 48. The next one maybe a 52. So we're decreasing in the amount of additional satisfaction that these hamburgers are giving us. The more hamburgers we eat, the less satisfaction an additional hamburger is going to get us. And then we see that we get to the point over here at 11 hamburgers, we have 70 utils of satisfaction, but one more hamburger at that point, the 12th hamburger, actually decreases our satisfaction a little bit. So we were at the level of 70, and now we are decreased to a level of about 67. So again, this is how satisfaction used to be measured historically using the old model. We're going to continue to talk about the old model for just a little bit more. Okay, so the previous slide showed us this top curve here. So that was the total utility curve. This bottom curve is showing us the marginal utility curve. So it is graphing out the increase in satisfaction from an additional hamburger at each point. So we can see here, when we move from 1 to 2, so in the middle of 1 and 2 there, we gain, our marginal utility is 10, moving from 1 hamburger to 2 hamburgers. Okay, moving from 2 hamburgers to 3 hamburgers, going in the center here, our marginal utility is also very close there to 10. When we move from 3 hamburgers to 4 hamburgers, we're a little bit lower here, maybe an 8. And then I'm going to have to write this over here. 4 hamburgers to 5 hamburgers. We're right here. Marginal utility maybe at a 7. 5 hamburgers to 6 hamburgers. Our marginal utility is about a 6. So you can see as we increase the number of hamburgers that we are eating, our marginal utility is decreasing, which makes sense again because the more and more hamburgers you eat, the less value that additional hamburger has. You can also see that we peak out here at a certain point, and that point is when the marginal utility is 0. That is when our total utility curve is going to reach its highest point. This is all defined by the law of diminishing marginal utility, which just states that marginal utility decreases as more of a good is consumed over a given period of time. So marginal, in the same sense, marginal utility increases as consumption decreases. So things become more valuable to us when we have less of them, and things are less valuable to us when we have more of them. Okay, so you are probably going to be given some problems on the homework and on the quiz that deal with marginal utility. So marginal utility, they're going to ask you to be able to calculate it. So here we have here the equation to calculate out marginal utility. So if you have the total utility and you have the quantity of hamburgers consumed, then you can figure it out. So this delta is change in total utility, and again, change in hamburgers. So to figure out, now we have multiple marginal utilities to figure out here. We can figure out the marginal utility from going from 0 to 1 hamburger, from going from 1 to 2 hamburgers, 2 to 3 hamburgers, and 3 to 4 hamburgers. So we're actually kind of figuring out the in-between the numbers here, okay, just to make that clear. So for the increased satisfaction that we will get from going from 0 hamburgers to 1 hamburgers, our change in total utility is 20, because we have 20 minus 0 divided by our change in the number of hamburgers. Well, we went from 1 hamburger or 0 hamburgers to 1 hamburger, so our change is going to be 1. So we have 20 minus 0 is 20 divided by 1. So our marginal utility in this first step is 20. Okay. I'm going to erase this so we can see for our next step. So our next step here, we're going from 1 hamburger to 2 hamburgers. And we went from 20 units of utility to 30 units of utility. So our change in utility is 10, because 30 minus 20 is 10. And our change in the number of hamburgers is, we went from 1 to 2, so that's 1. So 10 divided by 1 equals 10. So our marginal utility for this next step is 10. Okay, and now if we need to calculate the last one, or the third one, our change in total utility, we are going from 30 to 39, so that's a difference of 9. And we're going from 2 to 3, and that's a difference of 1. So our marginal utility is 9. And then finally, we have our total utility from 39 to 47. That's a difference of 8. And we're going from 3 to 4. That's a difference of 1. So our marginal utility is 8. So if we were going to graph our marginal utility curve here based off of our hamburgers, so we had 0, 1, 2, 3, and 4. And our marginal utility, if we were graphing that, we had between 0 and 1, we had 20. And then we went down to 10 between 1 and 2. And then we went down to 9. And then we went down to 8. Okay, so our marginal utility curve would look something like that. Again, the more we have of something, the less valuable it is to us. So our satisfaction or utility for the next item is going to be less than it was for the previous item. So you might see something, a calculation or problem like this. So again, we have the equation for marginal utility is the change in utility divided by the change in the number of items. So in this case, our change in utility here is 38 minus 18, which is 20. And then our change in coffee is 6 minus 4, which is 2. 20 divided by 2 is 10. So in this case, our marginal utility is 10. Again, putting a numeric value to the satisfaction that can be provided from goods is an old concept, but we can also apply this old concept to bundles of goods. So here, before we were talking about a single good, your text next talks about a consumption bundle, which means how much utility are you gaining from multiple different items, okay? So this is a cardinal number, again, which means it's a numeric value. So the calculation that was historically used to calculate the total utility of consumption bundles is just quantity of one item times the quantity of the other item. So very simple. We have multiple bundles of different quantities of hamburgers and different quantities of pizza. So our first bundle has 2.5 hamburgers and 10 pizzas. So if we follow the equation to find the total utility for this bundle, 2.5 times 10 is 25. So 25 utils. The second bundle we have 3 hamburgers and 7 pizzas. So if we multiply both of those, 3 times 7 is 21 utils. And then the final one, 4.0 times 6.25, that is also 25 utils. So if we had to rank what the consumer would prefer out of all of these combinations, well, bundle A and bundle C are tied. The consumer has no preference between whether they have 2.5 hamburgers with 10 pizzas or 4 hamburgers with 6.25 pizzas. They will derive the same satisfaction out of both of those, ranked at that 25 utils, and then their last choice would be the 3 and 7 combination with 21. So this brings up this idea of indifference. The consumer did not have a preference between bundle C and bundle A. That is a concept, this concept of indifference, while we no longer use, I'm going to put a big X through this, we no longer use numerical units to define satisfaction and utility of consumers. Rather, what we are using now is simple rankings. And we put those rankings on an indifference curve. Let's see what the next slide has. Yes, here's an indifference curve. So every single line on a single indifference curve. So this image has this yellow indifference curve that I made and then this green indifference curve. Those are two different indifference curves. However, every single point, any combination on this yellow indifference curve, whether it is 7 hamburgers with 2 tacos, or whether it is 4 hamburgers with looks like 3.5 tacos, or whether it's 1 hamburger with 7 tacos, every single point on that curve, the consumer is satisfied the same amount. So choosing between one combination or the other along this curve, the consumer wouldn't care. They are indifferent. However, every single point on this indifference curve is desired or provides more satisfaction than every single point on the lower curve, as it states here. The further the curve is to the right, the higher utility or satisfaction that those combinations bring. So remember, let me erase all this. These curves symbolize combinations or consumption bundles. Every point on here identifies a consumption bundle, a certain number of hamburgers with a certain number of tacos. Everyone on this red curve is valued more than everyone on this green curve. However, all points on the green curve alone are valued equally, just as all points on the red curve alone are valued equally. The same satisfaction is derived. So we call these indifference curves, and we also call them iso-utility curves. Iso meaning similar or the same. So every point has the same utility. We, unlike the old system where we used to we used to measure and define satisfaction in utils. We don't do that numerically anymore. It's just a ranking system with those indifference curves. So it's no longer a cardinal measurement, rather it is an ordinal measurement. This slide repeats what I just said. We can call them indifference curves or iso-utility curves. Again, another example of the picture. And again. Okay. So one piece of information that we can pull from the slope of the indifference curve is marginal rates of substitution. And marginal rates of substitutions they tell us how many of one product a consumer is willing to give up in order to receive one of another product. So we're dealing with tacos and hamburgers. So in this case, these indifference curves are going to tell us how many tacos is the consumer willing to give up in order to receive one hamburger, and vice versa. How many hamburgers is the consumer willing to give up to receive one taco? So let's check that out. So by looking at the slope between the points on this indifference curve, we are going to be able to figure out how many tacos this consumer is willing to give up to gain one hamburger, and how many hamburgers he or she is willing to give up to gain one taco. We call this a curve for a reason. It is not a line. There is a difference in the slopes between every point. Because it is a curve, the slope between this point and this point is different than the slope between that point and that point. Okay, so when I ask for a marginal rate of substitution measurement. So an MRS. When I ask for an MRS, I need to give you the 2 points that I'm looking for. So I may ask you, what is the MRS? So I'm going to write these out. MRS for marginal rate of substitution of tacos for hamburgers at MQ. Okay. In other words, how many tacos am I willing to give up for hamburgers? So I would be willing to give up, we can just look at the slope of the curve. So to go from M to Q, I'm going down 2 over 1. So I would be giving up 2 tacos to gain 1 hamburger. So marginal rate of tacos for hamburgers at MQ is 2 tacos for 1 hamburger. Okay. Now, if I wanted to switch that and say marginal rate of MRS of hamburgers for tacos, so marginal rate of substitution, I want to substitute out hamburgers to gain tacos. That one's a little bit trickier because if we look at this, to get 1 more taco, okay, so from Q to M, to get 1 more taco, right now we have 5 tacos at Q. To get 1 more taco, I'm giving up a half of a hamburger. So it would be a half. Okay. And then you can calculate the same thing for Q to R. So let's just do that really quick. And I'm going to word the question a little bit different this time. So I'm going to ask, how many tacos would I give up to gain 1 hamburger at QR? Okay, so we have Q, we have R. We're going from 2 hamburgers to 3 hamburgers. How many tacos did we have to give up? We went from 5 to approximately 4, we're going to say. So it was 1. The answer there is 1. Now if we went vice versa, how many, let's just say, I don't want to get rid of all of that, just this and this. Let's say how many hamburgers would I have to give up to gain 1 taco at QR? Well, here we go. I want to gain 1 taco. So I want to go from 4 tacos to 5 tacos. How many hamburgers did I give up? I went from 3 to 2. So that answer is also 1. Because at that point, the slope is 1. Okay. Okay, so this final part of the chapter deals with budget lines. If you recall that consumers decide what they're going to purchase based off of 2 factors. 1, does the item provide them satisfaction? And 2, does it fit within their budget? Can they afford it? Okay, so all of the work that we just did with the indifference curves addresses that first component of satisfaction. The work that we're going to do now is going to address the second component of budget lines, of affordability by working with budget lines. So a budget in general is the amount of money that we are willing to spend on a particular item or category of items. So since we've been dealing with tacos and hamburgers, let's just call this our fast food budget, okay? In order to create a budget line for fast food or for hamburgers and tacos, we need 3 pieces of information. The first piece of information that we need is we need to know our budget. How much money are we willing to spend? Are we willing to spend $10 a week on fast food, $20 a week, $5 a week? What are we willing to spend? We need to know how much each of the items cost that we are working with. At this point, we're only going to do 2 items. So we need to know the price of the hamburgers in this case and the price of the tacos in this case. So in order to create the budget line, as mentioned, we need that previous information. So here's an example of all of this information, and we're going to try to create a budget line. So first thing we do is create the 2 sides of the graphs, and I'm going to put hamburgers on one side, tacos on the other side. I've been given $5 a week to spend on tacos. Okay, this scenario must have been written a long time ago because $5 would not get you very far. And hamburgers are really cheap, and so is that taco price. However, okay, so my first step is going to be to find the extreme ends of the graph. Find extreme points of graph. What that means is if I spent all my entire $5 on tacos and I bought 0 hamburgers, how many tacos could I buy? Well, to figure that out, you're going to take $5 and you're going to divide that by 50 cents. Okay? Once you do that, you're going to realize you could buy 10 tacos. Might be able to do that in your head. So if I spent all my money on, if I spent all my money on tacos, I would be able to buy 10 of them. So that is my taco extreme point. 10 tacos, 0 hamburgers. Okay, nice. I need a second extreme point. And again, we're talking about budget lines here. Unlike the indifference curves, we were talking about curves. We're actually going to have a straight line. So our hamburgers cost $1.25 each. So how many hamburgers could we buy if we spent all of our money on hamburgers? To figure that out, we need to take $5 and divide it by $1.25. So $5 divided by 125 is 4. So we can buy 4 hamburgers. 1, 2, 3, 4. 4 hamburgers with the $5. Connect those 2 points, and that is your budget line. Now, if I had graph paper and if all of this was plotted out in proportion, we would be able to check out any line on this budget line to see all of the combinations that we could afford. Okay, you know, it would possibly be, here's 2 hamburgers and 5 tacos. There's a line right there. Okay, and then maybe 1 hamburger and 8 tacos. You have to do the math in this case to figure out because we don't have exact graph paper. Okay, so things can happen to shift the budget line and to change the budget line. So one of the things that can happen to change the budget line is that our budget can increase or our budget can decrease. So let's look at a couple scenarios of that happening. Okay, so this second one, we see here that our budget increased to $10 a week. But what I want to put on here first is our original budget line, because that's going to help us see some comparisons. So this was our original budget line with the $5. So the purple line is our $5 budget line, and then I'll do the $10 budget line in green. Okay, so now if we have $10 and we want to find those first two extreme points, we need to divide $10 divided by 50 cents, and that's going to be 20. So our extreme point, again, if tacos is over here and hamburgers is down here, our first extreme point then is all the way up here at 20. Just got to go off the chart a little bit. And then hamburgers are still $1.25. But again, our budget went up to $10. So if we spent all of our $10 on hamburgers and we divided that out, we would get 8. So 1, 2, 4, about right here. So our new budget line has shifted completely to the right. So that it exactly doubled because we went from $10 to $5. Okay. Third example we have here, I also want to keep our original budget line. We had the 1, 2, 3, 4 hamburgers we could afford, and then 10 tacos. That was our original line. Now something happened. The cost of tacos increased to $1 each. So if that happens, now we still have our $5 budget, but the cost increased to $1. So $5 divided by $1 is 5. So now we can only afford 5 tacos. So that's our new extreme point. The price of the hamburgers did not change, so that stays right where it is, but our new budget line is this red line. So the purple one was the original line. The red one is the adjusted line after the price of tacos increased. You'll see several examples on the homework of different shifts in the budget line, and you're going to have to figure out what happened. Did the taco price go up? Did the hamburger price go down? Did our budget increase? Did our budget decrease? So use these concepts to figure that out. Okay? Okay, that brings us to the end here. As we've discussed, this chapter was all about the theory of consumer behavior. And the first part we did indifference curves, because consumers behave based off of their satisfaction levels that they are deriving from products, and they also behave as a result of their budget and affordability. So this week we looked at the indifference curves and the budget lines separately. Next week we are going to bring the indifference curves and the budget lines together and talk about consumer equilibrium all on the same graph. So if you have any questions, as always, please feel free to contact me. And good luck on the quiz and the problems this week. And have a good rest of your week. Thank you.